Welcome to Civil Engineering Structural Design Team. My name is Kidana Malam. In the previous tutorial, that is tutorial part 3, we have seen that how to draw staircase, how to assign pier and spandrel on wall within detailed definition, how to assign diaphragm on slab, how to mesh slab. Today, I will show you how to assign and calculate vertical loads on beam and slab. After completing watching this video, you have to master ETABS software and structural designs of different projects. Don't forget that subscribe and share this channel to get more related videos daily. Let's start. Basically, building load is divided into two, that is vertical load and horizontal or lateral load. Vertical loads are loads that act toward the gravity or along the direction. That may be dead load or live load of the building, and that of lateral load or horizontal load is a load that acts laterally to the building. Lateral load is basically divided into three main categories. That may be lateral earth pressure or the load of the soil toward the building, and that of earthquake load, and the third one may be loads of wind or wind load that acts on the building. Today's tutorial is more basically about a vertical load, and we have seen in the next tutorial about applying a lateral load on the building of this project. To calculate a vertical load on this building, that may be on beam or on slab, that is area load. Basically, you must know about what is dead and live load mean, because vertical loads are most probably dead load, that may be the self weights of the building, and that of live load, that may be the load from people or the load from the furniture on the building. So I will show how to calculate vertical loads that may be dead and live load on beam and on slab respectively. This is a report file for this project. Loads on frame, that may be loads on beam. To calculate loads on beam, I have to divide it into two, that is internal beams for the internal beams and the external beams, because the thickness of the wall for internal beam and external beam is different. Mostly you have to use for external beam, you have to use 0.2 centimeter thickness of wall, and for the internal part, mostly you have to use 0.15 and 0.1 thickness of wall. So to calculate loads on beam and loads on slab, you have to refer your architectural plan. You have to refer your architectural plan. For example, the load for the external beam is mostly the thickness of the wall is 20, and for the internal part it's 1.5. So you must check one by one to design your building to become economical and more safe. So to calculate the loads of the beam, it's so simple. So the wall load on the external beam is equals to 0.2, that is thickness of 0.2, that is thickness of the wall, times 2.6, that is height of the wall, and L, that is the length of the wall, and times 40 kilonewton per meter square. This is the unit weights of HCB plus that of both side plastering, that is 2 times 0.02 thicknesses of plastering, it may be 0.03 times 2.6, that is the height of the wall, times L, that is the length of the wall, and times 23 kilonewton per meter square. That is the unit weights of plastering. So it becomes 10 kilonewton per meter. That is unfactored load for the external beam. You can calculate it by changing the thickness for the internal beam. The thickness to be 0.15 or 0.1 for 15 for thickness 15 and 10 thickness of HCB respectively. So this is how to calculate the loads of HCB wall on external and internal beams respectively. The other basic point is that how to calculate slab load or area loads of that of vertical load. Basically, vertical load is loads of dead load and that of live load. So on slab, we have three types of load, that is partition wall load and floor finish load under dead load and that of live load. Partition wall load is calculated as unit weights of HCB times thickness of HCB times heights of the wall or heights of the wall times length of the wall divided by slab area or panel area. And that of floor finish load is calculated as from Ethiopian Building Code of Standard or that of European norm. You can use 20% of partition wall load as that of floor finish load, or you can calculate that of floor finish load by adding these three terms, that is plaster, both side plastering of wall plus that of screed of the slab, that is 5 centimeter screed of the slab, and plastering of the ceiling, that is 0.02 or 2 or 3 centimeter thickness of slab, and divided it by the slab area or the panel area. You can calculate this. You can calculate that of the area load like this, and that of live load. You can use live load to up to 5 kilonewton. That is basically depends on the functions of the building. So using this load, you can assign on slab like this. You must calculate each panel load and put it as different to become more economical. And to become more safe, you can use the maximum panel load and assign on the project. This is assigned partition wall load, and this is also the assigned partition wall load. This is the assigned partition. This is the assigned live load, and this is the assigned floor finish load. Okay, thank you. After showing how to calculate load on beam and slab, I will show how to assign on the project using ETABS software. Okay. Go to plan. Go first floor plan. I will show one by one how to assign loads on beam and slab one by one using first floor slab, and we have finished today's lesson after assigning all the loads. First, it's better to make extrude shell and frame. So to assign loads on frame, we have calculate the load for the external and the internal parts of the beam one by one. So select all the external loads. Select all the external beams like this. Select all the external beams like this. So after selecting all the external beams, you have to go to assign, frame load, distributed load. After this, you have to select the load, that is partition wall load. Partition wall load. As I showed it before, the partition wall load for the external beam is 10. So 10 kilonewton per meter. You have to assign 10 kilonewton per meter. Make it apply. Okay. So 10 kilonewton per meter load is applied to all the external parts of the beam. The next one is that selecting the internal partition, selecting the internal beams, selecting all the internal beam. So after selecting all the internal beams, you can assign calculated internal partition wall load on the beam. Select it one by one. After selecting all the internal beams, you have to go to assign, frame load, distributed. That is the calculated value of all the internal partition wall load from the previous calculation is that 8 kilonewton per meter square. So apply. Okay. 8 kilonewton per meter wall load is applied to the all the internal beams. So it's good. After this, we have to proceed to assign dead end live load on the slab. So I have to select one slab and calculate all the load by cross-checking your architectural plan. For this tutorial, I have select this slab area and you have to calculate all the load, that is partition wall load and live loaders to this panel. You can calculate by using the tutorial I showed before. So we can assign a live load 2 to 5 kilonewton. Depends on the functions of the building. So you can refer it Tape and Building Code of Standard for more clarification. So for the tutorial purpose, I have to assign 2 kilonewton live load because it's the internal panel. For the internal part, you have to assign 2 kilonewton partition 2 kilonewton live load. If it is a residential, because it's a residential building, so have to go to select the panel, go to assign, shell, uniform, make it live. So you have to assign 2 kilonewton per meter square live load, make it okay. For the cantilever part, you can assign 4 kilonewton per meter square. After assigning the live load on the slab, it's better to assign the other loads that may be floor finish or that of partition wall load. For floor finish load, you can calculate it in detail. So you have to assign 1.7. Go to assign shell uniform, make it floor finish. So for floor finish load, you have to assign 2.1 kilonewton per 2.1 kilonewton per meter square floor finish load to this slab. And the other one is that the partition wall load, that is the partition. Okay, what is the location between 3 and 4? between 3 and 4. That is the partition wall of this. You can calculate it in detail, and it may be up to 2.5 kilonewton per meter square. So have to assign partition wall load on your slab looks like this. That is partition wall load. It's up to 2.4 or 5. Calculate it in detail, or calculate it using the previous formula that I have to show. Make it okay. It's better to stop today's tutorial here. In the next tutorial, that is tutorial part 5, we will see how to assign lateral loads, that is earthquake load, wind load, and lateral earth pressure load on this building. Thank you. Subscribe my YouTube channel to get more updated videos daily. Goodbye.